Okay, so today we're going to be going over a basic problem that involves a few definitions that you should know. Let's get started. So, you're given a system consisting of three particles. You have one particle, which we call M1, which has a mass of 5 kilograms and a given velocity. We have M2, mass of 6 kilograms with a given velocity. And we have M3, which has a mass of 3 kilograms with also a given velocity. Our first question is, what is the total momentum? Now, as we know from earlier chapters, momentum equals mass times velocity. And here, the total momentum is asking for the momentum of the system. So what will that be? It would just be the summation of all the momentums. So here's that formula. You would have M1 V1 vector plus M2 V2 vector plus M3 V3 vector, which then, as I have calculated these answers, you'll get this value. And remember, this value is the momentum of the system. Next question. What is the velocity of the center of mass of the system? And you can derive what the velocity of the center of mass of the system will be from your basic momentum principle, or not, rather, just momentum definition, which is the momentum of the system equals the mass of the system times the velocity of the center of mass, which you can isolate your velocity of the center of mass, and that will equal the momentum of the system over the total mass, or the mass of the system. And the mass of the system is simply all of your masses added together. So M1 mass plus M2 mass plus M3 mass, and I've calculated this value. Next question. What is the total kinetic energy of the system? Now remember from our knowledge of energy that kinetic energy, a basic definition, equals 1/2 mv squared. But you need to remember that energy is a scalar quantity. So you need to have the magnitudes of the velocities of the particles in order to solve this. So remember another basic definition. The magnitude of the velocity equals the square root of the x component squared plus the y component squared plus the z component squared. After calculating that, you can then get the total kinetic energy, which will be the summation of 1/2 mv squared of all of your particles. And you'll get this value. Next question. And this is kind of a new definition. So, what is the translational kinetic energy of the system? This definition is very, very similar to just the normal kinetic energy that you have already learned. 1/2 m total v center of mass squared, which I have calculated, and here's that value. And we have one more question. That question is, what is the relative kinetic energy of the center of mass of the system? Relative kinetic energy can be seen in this equation and can be solved for like so. Relative kinetic energy is equal to the total kinetic energy minus the translational kinetic energy. And here's your value. As stated before, this was just a very, very simple example that involved a few definitions that you should already know, and a few new definitions. And these definitions and formulas can be used to find different values for this particular real system given in this example.